In this video, we're going to be going over a useful tool in probability called a Venn diagram, and then we're going to use that Venn diagram to explain what a union and an intersection are. So a Venn diagram starts off with a simple rectangle. So we're going to draw this rectangle, and this rectangle just represents the entire sample space for a particular experiment. And our experiment that we're going to be using for our example is the experiment of rolling a single die and the outcome of that. So our experiment, or our sample points for our experiment, are going to be 1, 2, 3, 4, 5, and 6. So now that we have these sample points written in our Venn diagram, or sample points written in our sample space, we can use it to designate particular events occurring in that sample space. To do that, we're just going to draw a circle around the points that we're going to consider in our event. So for our first event, we're going to say that our event A is if we roll a value less than 4. So we're going to say event A is 1, 2, and 3. So if we roll a 1, 2, or a 3, we're going to say that event A has been satisfied and considered a success. So to designate that in our Venn diagram, we're just going to draw a circle around our 3 points that are in our particular event. So we have this event now drawn in our Venn diagram, and we can actually just add other events also. So let's say we want to add another event. We'll say event B. And event B has 2 points in here now. So if we roll a 3 or a 6, or any value divisible by 3, so we'll say 3 and 6, we're going to say that that satisfies event B. So event B is just rolling a 3 or 6. So if we want to put that in our Venn diagram, we just circle 3 and 6, and we're designating that now as a new event inside of our sample space. So now that we have our Venn diagram set up with our 2 events, let's talk about what a union and an intersection are. So the first, we're going to talk about a union. So if we say we have a union of events A and B, which we can write as either A union B or B union A, and these two are equivalent, so we can have them commute back and forth. So A union B or B union A, we're going to say that that's a new event where we have either event A or event B, or both of them happen. So this is just a new event, a new way of designating an event. So if we look at what A and B are, we can see that we could actually write this in a little simplified way. We can say that we can write that as, if it's event A, we have 1, 2, or 3. So we'll write 1, 2, and 3. And then we also have the parts from event B. So we have a 3, which we already have in here, so we don't need to write it twice. And we have a 6. So we have A union B, where A is equal to 1, 2, or 3, and B is equal to 3 or 6. And we're going to say A union B is equal to 1, 2, 3, or 6. So we're going to consider event A union B satisfied if we roll a 1, 2, 3, or a 6. Now the intersection of that is kind of the flip. So we're going to say the intersection. And we're going to write that with, instead of a right side up U for the union, we're going to write that as an upside down U. So we're going to say that A intersect B, which is equal to, again, B intersect A. And we're going to say that it needs to satisfy both events inside that intersection. So if it satisfies A but doesn't satisfy B, it is not a part of that intersection. And if it satisfies B and doesn't satisfy A, it is also not a part of that intersection. So if we look at both of our events A and B, we see that they only have 1 point in common. So basically 1 point that satisfies both A and B. And we see that that point is 3. So we're going to say that the intersection of A and B, or the intersection of B and A, is just equal to a single point, which is the point